Very good morning to everyone. In this lecture, EC 8791 Embedded and Real Time Systems. In previous classes, we are going to discuss the embedded programming in embedded system design. What are the components we are using in embedded programming, and what are the models of programs? That is, how to interface with the other interfacing devices like a processor to co-processor units, the how what are the different instructions we are followed in our embedded C language, and how do the language can be executed through the different modules, application modules are there. So in today's session we are discussing the embedded programming in assembly level, and also the how to link the programs in your interfaces devices, and how to load the programming. Here we can see the block diagram, the assembly and linking. It is the last step in the compilation process. So once the program we have to write up, we have to go to the new project and we have to execute, or we have to compile. We have to, there is a compilation. You have to check your syntax. So the steps in the compilation process, they convert a list of instructions into an image of the programs bit in your memory, and also the loading. It's a loading is the put the program in memory so that it can be executed. First one, the first block of the high level language coding. It is a basic level C level coding. We are compiled through the coding. So it is a second process. It is check the syntax of this coding, and also we have to convert to the assembly language coding. So the compilation technique, it used to convert, that is a high level language code to assembly language code, that is a bit level language code. Then the assembly language code, it is assembler. So the compiler used to create the instruction level program into the assembly language coding. Next is the assembler. What are the function of the assembler? The assembler used to translate the symbolic assembly language statement into the bit level representation using the different kind of instructions. So the assembler, it used to translate the symbolic assembly language statement into the bit level representation of instructions. It is known as the object code, and also the translating labels into the address. The linker, so that it determines the address of the instructions. What is the functions? So every individual data we have to store in the different registers. That is a different addressing registers. So each individual addressing register we have to denote it as a label. So address of the data, so location of the data, and also we have to encapsulate the identity of the data. So the linker determining the addresses of the instructions, and also the loader, the load the program into the memory for execution, and absolute address. So the assembler assume that the starting address of the assembly language program has been specified by a programmer. Then the relative addresses, it is specifying at the start of the file header is to the computed later. So the assembler is a main think of the translating the assembly code into the object code, and also the assembler must translate the object code and format the bit in each instructions and translate the labels into the addresses. So what is a label? It is an abstraction provided by the assembler, and also it is known as the location of the instructions and data. So the label processing required to make the two passes, first passes and second pass. The first pass is the code, scan the code to determine the address of each label. What type of data we are move, or what type of data we are sending, what type of data we are conditional logical functions. It is a first pass. Second, the label processing of second passes. The second pass, it is assemble the instruction using the label value computed in the first path. Next, linking. The linker allows a program to attach it together out of several smaller pieces of data. It is called as linker to link the object. So the linker operate on the object file and a link between the another interfacing files like a memory location. In some labels will be both defined and used in the same file. The other labels will be defined in a single file but used elsewhere. So the place in the file where a label is defined is known as the entry point. The place in the file where the label is used is called as an external reference. It is a phase of linker. So here the linking is two phases. Phase 1, phase 2. There is a phase 1, it determine the address of the start of each object files. And phase 2, second phase, is a loader merge all symbol tables from the object file into the single large tables. So the two phases, it determine the address of starting of object file and merge the loader into the symbol of data tables and from the object file. So here the complete set of blocks, that is a high level language coding blocks and compiler, how to the high level language code into the assembly language code, that is a bit level instruction code language, how to compile through the data to the different peripheral units. So different peripheral units we have to assembled, we have to compile the same instruction set in our processor. So we are adding the external peripheral device in our in the processor. It adding the control. For example, we are adding the external peripheral device in the controller. For example, the timer controller. We are example the analog and digital converters and keyboard interfacing and stepper motor interfacing. So those so many interfacing or we are interfere with the processor. So the linking, it accumulates to connect with the two phases, that is a direct linking between the processor, that is a address of the start of the object file. So first approaches, that is it is a quick operation of the first object data, it can be executed. Then the second phase, that is a load the specified registers, specified locations. The specified locations, it is loaded in this symbol of tables that in the object from the object file. Then the executed binary data will become the loader. The loader load the data to the executed integrated, that is application specific integrated design modules. It is a complete set of the software level, the software programming level in the set of variety of different interfacing we are added to the embedded system design. So we have to reduce the power consumption, we have to reduce the density of the size of the programming, we have to optimize that the assembly linking and loading operations. Now in this session we are going to study the what are the embedded programming and what are the technique of assembling and loading and linking process we have to done in embedded system design processing. Thank you for watching this video.